Hello everyone. Today we are going to learn the principle of moment. In order for a rigid body rotating around a fixed axis to be balanced, the total moment of force that causes the object to rotate clockwise must be equal to the total moment of force that causes the object to rotate in the opposite direction. The rotation effect of a force acting on an object is determined by the formula F equals F times D. Principle of moment. F equals F times D. So, how to determine the rotation effect of a force acting on an object? We have a scenario as follows. When a boy acts on the door, if the force is greater, the door will rotate easier. On the other hand, if he keeps the magnitude of the force and change the position of the force away from the hinges, the door also rotates easier. However, if the boy has the force to go through the hinges, the door does not rotate. Conclusion: the rotation effect of the force depends on the magnitude, position, and the direction of the force. However, we do not know specifically how does the rotation effect of the force depend on these factors. This scenario will create a condition to develop the problem in a natural way. In order to solve the problem mentioned above, we will have to use the experiment to determine the magnitude, position of the acting point, direction of the force acting on a rigid body with a fixed rotation axis. Then we apply a variety of forces to make the object equilibrium. Observe, evaluate how these forces are connected, thereby giving the concept of spinning effect. To conduct the above solution, we will use the following sample. The rigid body rotating around a fixed axis is a circular disc with concentric circles and holds a long radius. The holes are numbered from 10 to 80, and the distance between the holes is 1 centimeter. Applying F1 and F2 on the same diameter so that the disc is in equilibrium, we notice that the object tends to rotate in opposite directions when F1 and F2 acted respectively on the disc, and the magnitude of the forces F1 and F2 will be proportional to the position of set points of the force F1 R1 equal to F2 R2. The hypothesis is that the rotation effect depends on the product of the magnitude of the force and the distance from the point to the rotation axis. Maintain the position of the disk by hand. Keep the magnitude of force F1, F2 and its position. Change the direction of force F2 with the fixed pulley. With the hypothesis is correct, then the disk will continue to balance when we release the hand. Because the disk rotated, the hypothesis is not correct. Set the disk back to the original equilibrium position. Change the position of the force F2 to make the disk equilibrium, so there exists another F2 location to balance the disk. Why not satisfying the expression F1 R1 equal to F2 R2, proving that R1 R2 is just a special case. We will find the special feature of R1 R2. Observe again, we see not only the distance from the set point of the force to the axis of rotation, but R1 R2 is also the distance from axis of the rotation to force vectors D, because set points of F1 F2 lie on a diameter. From this scenario, the rotation effect also changes as the direction of the force changes. When the force changes simultaneously, D will change, consistent with the imbalance of the disk. Hence, the assumption is F1 D1 equal to F2 D2. The hypothesis is verified by using a rotating circle to measure distance D1 D2. Make a table for D1, F1 D1 and F2 D2. So, in conclusion, the result of the experiment shows that the rotation effect of the force is determined by the formula F equal to m equal to F times D, with F is the magnitude of the acting force, D is the m, which is the distance from the axis of rotation to the straight line passing the force vectors.